Hello and welcome to ICND1 Lab 4, Finding the Subnet Number. This video demonstrates a process by which, with no binary math, you can find the subnet number in which an IP address resides. In particular, this video shows how to find the resident subnet for IP address 128.200.100.100 with mask 255.255.224.0. Also, if you're following along with the Cisco Press exam certification guides, note that it's best to have read Chapter 12 of the ICND1 book before watching this video. This video has both a tactical objective as well as a strategic objective. Tactically speaking, the goal of this video is to help you understand how to use a particular process to find an IP address's resident subnet. Every IP address sits inside some subnet, and we call that the resident subnet. Now, the strategic objective is to help you prepare for answering subnetting questions on the CCNA exams, in particular that you be able to answer those questions quickly and with confidence. The Cisco Press ICND1 and ICND2 exam certification guides describe a process for how to find the resident subnet even when a difficult mask is used and with using no binary math. Now, when I say difficult mask, I mean it's a mask that has one octet that is neither a 255 nor a 0. In these cases, most people have a difficult time intuitively seeing what the subnet number is. This video uses the same process that's explained in those books. Before taking a look at the process, let's take a closer look at what I mean by resident subnet. Every IP address assigned to a host when subnetting is used is inside a single particular subnet. So the resident subnet is the subnet number of the subnet in which an IP address resides or an IP address is a part of. For instance, here in the figure we have PC1, and it's been assigned an IP address of 128.200.100.100, and it's got a mask of /19 or 255.255.224.0. Now the question is, what is the subnet number in which this IP address resides? As it turns out, the subnet number is 128.200.96.0 with that same /19 mask. Now, why do we care? Well, one reason you might care is that router R1 that's connected to that subnet is going to end up adding a route to that connected subnet to R1's routing table. Here we see a representation of R1's routing table that lists that subnet as a connected route off the Fast Ethernet 00 interface off R1. If other routers existed in the picture, R1 would then advertise a route for that same subnet to the other routers that exist. Now, another fact you might want to know is, what's the range of IP addresses that can be used inside that subnet? For instance, if you added another PC to this subnet, what would be a reasonable IP address to choose that would be a legal IP address? Lab 5 shows how to answer that particular question by showing a process through which you can find the range of IP addresses in a subnet along with the subnet's broadcast address. The video now shows a copy of the written process that will be demonstrated by this video. This written process is taken from the Cisco Press ICND1 exam certification guide, but the point of this video is to show this process in action. It's included here in the video so you can easily move back to look to it. Also, the booklet that comes with this video product lists the same process for your reference. To begin, you can use an empty table that leaves a convenient place to put the subnet mask, IP address, and resulting resident subnet number. Now here at step 1, we simply copy the mask and IP address into the table. Then at step 2, we draw a rectangle around the interesting octet. Now the interesting octet is identified by the subnet mask octet, whose value is not a 255 nor a 0. In this case, it's the third octet with mask value 224. Next, at step 3, we'll identify the values in the three uninteresting octets. First of all, at step 3A, we'll look for any octets to the left of the rectangle and simply copy the IP address's value down into the subnet number. Here we see we'll start with 128.200 in the first two octets. Then for any octets to the right of the rectangle, we'll simply write down a 0. So now we've got 128.200.something.0, and the fourth step will then fill in the something in the third octet. Now at first glance the process may seem a bit odd, but it always does give the correct answer and it doesn't require any binary math. The first part of step 4 starts with the calculation of the magic number. The magic number is calculated as 256 minus the mask's value in the interesting octet, which is 224 in this case. So in this case our magic number is 256 minus 224, or 32. Now there's nothing particularly magical about it, it's just a word I use to describe this particular number. Now, as it turns out, the resident subnet number in the interesting octet is a multiple of this magic number. So at step 4b, we're going to calculate all the multiples of the magic number. We start with 0 and calculate all the way up through 256. Now the subnet number's value in that third octet is going to be one of those numbers, but which one? So at step 4c, we compare the IP address, not the mask, but the IP address's value in that interesting octet to the list. Now that value is 100 in this example. And we see that 100 is closest to the multiples of the magic number that are 96 and 128. And we simply pick the smaller of the two. So in this case, we pick 96, so the subnet number is going to be 128.200.96.0. This concludes IC&D 1 Lab 4. This video has mainly shown you how to find the resident subnet without using any binary math. It's also given you a tool that can help you answer subnetting questions on the CCNA exams both quickly and with confidence.